Okay, in this lesson, we're going to study prime factorization. And just to review, prime numbers only have two factors, 1 and then that number. Prime factorization is searching for all the prime numbers that when multiplied make up that number. So for example, if I'm looking for all the prime numbers for the number 12, I'm going to split this number up into different factors and make a factor tree. And the reason why it's called a factor tree, it kind of looks like a factor pine tree, if you will, or spruce tree. It starts at the top with the number that you're searching for all the prime factors for, and then it branches off, okay? Branches going downwards. So I'm going to think of two numbers that when multiplied give me 12, or two factors of the number 12. And I know that 12 is an even number, so I know 2 is one of those factors. And I know that 2 times 6 equals 12, so 6 is the other factor. So I start off with these two factors right here, okay? Now 2 is a prime number because no other number other than 1 and 2 can be multiplied to give me 2. So 2 is already a factor, or a prime factor, and so this branch is closed off. However, if I think of the number 6, 6 is a composite number. It's not prime. So I know that I have at least two numbers that I can multiply to get 6, and those two numbers are 2 and 3. So I have branched off from 6 the two factors that give me 6, which are 2 and 3. And 2 and 3 are also both prime numbers. I'm actually going to get rid of this circle just to not make it confusing. Okay, so I have 2 and 3, which are both prime numbers that multiply to get 6. And 2 times 6, this 2 is also prime. So all of my prime factors that when multiplied give me 12 are 2, 2, and 3. And if you think about it, 2 times 2 is 4, and then 4 times 3 is 12. So those are the prime numbers that when multiplied give me 12. And so 2 times 2 times 3 is the correct way to write the prime factors of 12. Let's look at two other examples. If you think you know how to do it, you can go ahead and pause and try it on your own. Or if you want to walk through it one with me and then pause for the second one, you can do that. We're going to look for our prime factors for the number 84. Okay, and I know that 7 times 12 is 84. So I'm going to start off with 7 and 12 as my two branches. Okay, and I just know that because I know my 7 facts, and I just remember that 7 times 12 is 84. Well, 7, if you know your prime numbers, is a prime number, so we're going to go ahead and leave that one alone, circle it. However, 12 is a composite number. We can break it down further. And there's a couple different ways that you can break 12 down. You can break it down into 2 times 6 or 3 times 4. So let's go ahead and do 3 times 4, because 3 times 4 gives me 12. Well, guess what? 3 is a prime number, so I can go ahead and circle off that branch. And 4 is a composite number. I have 2 times 2, which will give me 4, and those are both prime numbers. Okay? So my prime numbers, my prime factors for the number 84 are 2 times 2 times 3 times 7. And if you multiply those out, you should get 84. All right, last one, 99. Well, if it's a double digit, then it has to be divided or divisible by 11. So 11 times 9 is 99. Okay? I automatically know that 11 is a prime number, so I'm going to circle that off. And 9 is a composite number because 1 times 9 is 9, but also 3 times 3 is 9. And as we saw over here, 3 is a prime number, so we'll circle those off. So the prime factors of 99 are 3 times 3 times 11. And that is prime factorization using factor trees.